Welcome, Hornets, and thank you for joining me today. Today we are looking at a more extra practice. And in this extra practice, you'll notice I have a chart and I have a particle moving along an x-axis, and we have a function given here. And we're probably going to need to use our calculator for this, unless, of course, you know your trig exceedingly well. And what I found is a lot of people are still struggling with that, so we'll be using our calculator for part 2, but we will be using the table for part 1. So let's go ahead and begin. I'm going to go ahead and I'm going to zoom in on this just so that we're looking at the table. We can clearly see it and the questions. So the first thing I want to do is recognize they say that h and g are inverses, and we want h prime of 1. This is RDIB. So we're saying that h prime of 1 is going to have to be 1 over g prime of some value. And if this h, and you notice there's no h in the chart, has a 1, according to the points, they had to flip. So if I were looking at g, this is the y value in g. So I'm going to look along the g column, and I'm going to find where I have a 1. And you'll notice that 1 matches with x equals 0. So I'm now putting a 0 here, and I'm now ready to look for g prime of 0, which is 5, and my answer is 1/5. They then say, find the equation of the tangent line to h of x equals 3. And we have to use our inverse. Well, that means that this is the y value, this is the x value of g. G of 3 equals what? So I'm going to find g of 3, and I find that I have a 0. Then I'm going to find h of 0 as a derivative, and it has to be 1 over g prime of 3. So g prime of 3 is 3. We're looking at 1/3, and I'm now ready to put it all together. So we would have h of x minus our 3 equals 1/3 x minus 0. So here's my point, 0, 3 for h of x with a slope that's 1/3. And this is the equation of my tangent line. We're now going to go to C. We're now told that c h of x is the square root of g of x. They want me to find h prime of 5. So I'm now going to look at g as g of x to the 1/2 power. And that's what I'm going to take my derivative of, d dx. I'm going to get 1/2, following the chain rule, of g of x to the negative 1/2 power times g prime of x. And I can now plug in 5. So I want 1 over 2 times the square root of g of 5 times g prime of 5. Well, what is g of 5? G of 5 is 4. So I have the denominator 2 square root 4. And up in my numerator, I have g prime of 5, which is a 2. I'm now going to reduce it, and I get 2 over 4, which gives me 1/2. And my answer to 1c is 1/2. This now brings me to the second question. And we've been working with our calculators for a little bit, so this just follows along. We're going to start by turning it on and go to y equals. We want to put in 2x sine x squared minus x plus, close parenthesis, plus cosine of x. Please make sure your mode is in radian mode. And our windows are the domain 0 to 4. I'm going to hit Zoom Fit. Zoom 0. This is going to give me a graph that will be the best looking graph I can. Here we go. When is the particle at rest? Well, if this is my velocity function right here, I'm looking at rest wherever I have 0 values. And there are 3 of them. All right? So here we go. Let's find our first one. Alpha, trace, find the first 0. We want to be to the left, which will put it above. And we're going to find our second value. That'll be below, and therefore to the right. Then we hit enter. And our first value is 2.3016. So the particle is at rest. When v of t equals 0, equals 0, excuse me, and this occurs at, and then I'm going to put my x values. X equals 2.3016. You'll notice I went to the 4th decimal place and truncated. I'm now going to find my second 0. So second trace, find my 0, left, right, and we now have 3.0875, comma, x equals, and these are approximate values since I have rounded them, 3.0875, and now I'm going to find that last one. That's going to be right here. Watch out for the glare, Mr. Lamb. Second trace, find my 0, above to the left, below to the right, and I get 3.5901. And there we go. The particle is at rest when the velocity v of t equals 0, and this occurs at, and I give my values. When is the particle moving left? Well, the particle has to be moving, and there went all of my lights, but that's okay. Hopefully it'll cool down the room. So I know the particle is moving left when velocity is negative. That's going to be between these two zeros and from here to my endpoint. Alrighty, so the particle is moving left. When v of t is less than 0, and this occurs on, and now I'm going to use parenthesis 2.3016 to 3.0875 in union with 3.5901, comma 4. Now please be aware, when we talk about velocity, we are talking about open intervals, as we need two-sided limits, and so I'm going to be using these values. The next question says, at 2.5, is the speed of the particle increasing or decreasing? So we're going to find our value. Second trace, 2.5. So 1, 2.5. Now I can see, number 1, my velocity is negative, being below the axis, and I can see that my velocity is decreasing. When velocity is decreasing, acceleration is negative. So let's go ahead and write that. We have velocity, v of t, v of 2.5, excuse me. Let's make sure you can see that. 2.5, and that was less than 0. And a of t, 2.5, was also negative less than 0. Alrighty, so the speed of the particle is increasing because v of t, v of 2.5 is less than 0, since v of 2.5 was below the x-axis, and a of 2.5 was less than 0, since v of t is decreasing at 2.5. So velocity and acceleration, and I could have put v of t and a of t, have the same sign. And there we go. There is my answer to all 3 of those questions. That's how it works. I hope this worked for you. If you found this to be a positive video, please remember to click like. If you have constructive criticism, please let me know how I can improve, and I will do my best. Thank you very much, Hornets. Please be safe and take care. Cheers.